So for the following section, we're going to be talking about horizontal asymptotes, vertical asymptotes, and slant asymptotes. So to start off with, we're given f of x equals 1 over the quantity of x minus 2, and we want to find f of 2. So our function, written normally, would look like this. F of x equals 1 over x minus 2. So with this, we want to find f of 2. Well, we know that if we were to plug 2 into this function, we'd get 1 over 2 minus 2, which gives us 1 over 0, which is undefined. So f of 2 is undefined, and normally we would just stop there at this point. But we really want to define what exactly this is. We don't want to just keep saying undefined, because there really has to be something happening here if we were to look at the graph. So what we're going to do is talk about what happens when we approach this value of 2. So what happens when we get really close to 2 on the left and really close to 2 on the right? What will the graph look like? So let's go ahead and start on the left. What if we were to plug 1.9 into f of x? So f of 1.9. Well, if we did that, 1.9 minus 2 would give us negative 0.1. And 1 divided by negative 0.1 gives us negative 10. Okay, now what if we tried 1.99? So we're getting even closer to 2. So 1.99 minus 2 would give us negative 0.01, and 1 divided by that value would give us negative 100. Now this is kind of interesting. By just going a distance of 0.09 on our x-axis, our y values have jumped a distance of 90. That is a tremendous jump that if you tried to graph that by hand, you really wouldn't even be able to on a standard xy coordinate plane without changing the distance between the interval marks on the plane. And it just so happens that if we were to try 1.999, we would get negative 1,000. And you can probably guess where this is going to go if we just keep adding 9s. It's going to approach negative infinity. Okay, so from here, what if we tried 2.1? Let's look at this graph on the right side of 2. If we plug in 2.1, we get 2.1 minus 2 is 0.1, and 1 divided by 0.1 is positive 10. So you can probably guess what happens when we plug in 2.01. We get 100, and 2.001, we get 1,000, and this number starts approaching positive infinity. So what's happening here? As we approach 2 from the left side, our graph starts shooting down to negative infinity like this, and as we approach 2 from the right side, our graph shoots up to positive infinity like this. And it just so happens that it'll look something like this. Now, it's not exactly this graph, because this graph is shooting down to negative infinity at x equals 0 and shooting up to positive infinity at x equals 0. But it's the same phenomenon that's happening. We have a vertical asymptote at x equals a, at some value a. And we say a vertical asymptote like this exists if as x approaches a, f of x approaches infinity, or f of x approaches negative infinity. So it doesn't necessarily have to look like this, where one part's shooting down to negative infinity and one part's shooting up. It can also look like this, where both values are shooting up to positive infinity, but they will never actually reach each other. They'll never actually touch, because if you plug in this value, you'll get an undefined, just like we have here. And it can also look like this, where both values are shooting down to negative infinity. But again, it's the same thing. There is a vertical asymptote. And the way that that's drawn is you'll see a dotted line. Whenever you see a dotted line on your graph, it means that you have a vertical asymptote. It means the graph will never actually touch that value. Now, I should be clear about this. This is with vertical asymptotes that's true. It is possible, for our next definition, a horizontal asymptote, for your graph to pass through a horizontal asymptote. And a horizontal asymptote exists at y equals b. So for some y value, like y equals 5, there could be a horizontal asymptote if, as x approaches infinity or x approaches negative infinity, y, or f of x, approaches some value b, that y equals b value. Now this seems a little bit more complicated to think about, but we've actually already shown an example of this. In the following problem, y equals 0 has a horizontal asymptote. Notice as we approach y equals 0, the graph shoots off to x equals negative infinity, or x approaches negative infinity is the more technical way to say it. And as x approaches positive infinity, the graph is approaching y equals 0, but it will never actually reach that value. Again, there are some cases of a horizontal asymptote where it can reach that value, but for this example, it does not. These lines just plateau as they approach y equals 0.